Assalamualaikum and good morning to my panel, Dr. Ahmad Rizalik and Dr. Siki. My name is Muhammad Akhiruddin bin Ibrahim and my metric number is DE190148. Today, I will be doing video presentation for my final year project, which is IoT control-based water quality monitoring system. So, without any delay, let's proceed to the video.
The content will separate on 8 different parts, where we will go through the project background, problem statement, objective, scope, methodologies, result analysis, conclusion, and finally is recommendation for future work. Water is require proper care to bring the best quality of water, as water is easily contaminated with microorganisms, toxic, and human waste. The water itself contains pH level. The average pH level needed for the water that is safe on human consumption is around 6.5 until 8.5 value. If the human drink on higher or lower level water, it corrosive to biomembrane and can incite damage to the tissue. The water temperature also have effect on the water quality. It might be dangerous and can contain microorganisms. Thus, the IoT-based water quality monitoring system for lake will consistently monitor the water pH value and the temperature value. The concept is appealing, but there are several constraints that must be addressed before the system can be installed in lake. The following are restrictions that must be considered is the resident might lack of knowledge related to water pollution on microorganism level, as microorganisms cannot be seen by naked eye. The project likely used only for a short amount of time. The previously pH sensor and temperature sensor could only collect data in one area. And lastly, the maintenance and the value of the project component are quite costly and hard to maintain. So there are some of the objectives have been changed from the previously presentation. The first one is we want to develop an independent water monitoring system that can move on command freely. The second is we want to monitor the pH and temperature value of the lake water. And lastly, we want to analyze the functionality of the water quality monitoring system. On scope project, the first step is to receive and send data. The node MCU ESP32 is connected to the Arduino Uno through network and Wi-Fi. The BLYNK application system are capable of handling operation in stable network coverage. The BLYNK application provide input to the IoT system, which then enable the microcontroller to move the board by sending command to it. The ESP32 is a tool for data processing for lake water, pH level and temperature level to monitor water quality, in addition on controlling the board movement. And finally, the board design concept is in accordance with the design requirement to preserve stability and durability while being tested in various locations with various environmental conditions. On the methodology part, the flowchart is separate to two different processes. The first one is the flowchart for the project, and the second is the flowchart of the system. For the flowchart of the program, basically, we'll talk about our thesis, where the first step is we'll run the background studies on the thesis for the IoT-based water quality monitoring system. And then we proceed with the literature review, where we'll be find the previous paper on the IoT-based water quality monitoring system. And then we start with the process on listing of component used for the billing and costing material of the project. Then we can proceed with the hardware development and software development. For the hardware development, consists of the connection of the circuit, and the software is mainly on BLYNK and Arduino IDE coding. Then we will proceed with the analyze and troubleshooting process. If we are unable to gain data, we will analyze and troubleshoot again on the hardware and software part. And if the data is successfully analyzed and troubleshoot, we will be collecting data and compiling it on the chapter 4 of this thesis. So for the system of the IoT control-based water quality monitoring system, it starts with the Wi-Fi is connected. the ESP32 will link with BLYNK. And when in link with BLYNK, we can try to move on the BLYNK application on checking servo motor and motor driver are function or not. If we press the joystick on the BLYNK application to move forward, the boat then will be moving forward. If no, the boat will not move. If we choose on moving backward, the boat will also move backward. Same goes as for the if we choose on the joystick for the input left and right. If we choose left, the boat will go left, and if we choose right, the boat will go right. So we'll proceed with the reading on pH and temperature sensor. The first step is the initialize of the software series on MCU. The send entry data from MCU to MCU base. The pH sensor and temperature module will read and receive analog data. The ADC will go to ESP32, while the data processing to calculate the value of the focus area. If did the sensor read the value? If not, it will be repeated the process again until we can receive the value. The data then is sent to the BLYNK application. The BLYNK application is located on our smartphone where finally it will display the notification that if the pH value change if the pH and temperature value changes, it will update on the BLYNK application. So here is the connection where separate on three different parts: the input, receiver, output. So the BLYNK will be sending signal to ESP32 on controlling the boat. The sensor of the pH sensor and the temperature sensor will connect to the pin at the ESP32 and ESP base, and the power supply use lithium-ion battery to supply the power to the ESP32 and base. By doing so, the BLYNK platform can use to control the motor driver and servo driver. When the ESP32 receive the data, the motor driver can move and the propeller will move from the motor driver. And the BLYNK will be displaying the sensor data at the BLYNK application. So for the result and discussion, we take the data of the lake at the artificial eustachian lake, and we can see the table on the right side is the parameter and geometric. The area of the lake is around 4067.18 meters square. The perimeter is 343.77 meter. The water level is 1.136 meter based on the observed data. The wind speed is 5.56 meter per second to 8.33 meter per second according to Malaysian Meteorological Station, and mean surface is around 28.8 Celsius, and finally is total precipitation is around 50 to 350. So we can see the figure show that the data is taken from 5 different spots of the lake where has been labeled as A, B, C, D and E spot. So for the A spot, the pH level is 6.75, B is 8.97, C is 8.33, the D is 8.14 and E is 7.97. The variation in pH value may indicate there are different sources of acidity or basicity in the lake which could potentially affect the water quality. The low alkalinity of the lake could possibly be attributed to free carbon dioxide, which is natural component of water. Carbon dioxide can lower the pH of water by forming carbonic acid, which can dissolve in water and lower the pH. Additionally, the lake could be affected by different acid and alkalis that can enter bodies because of industrial waste around the campus. The high pH value that were observed during the sampling period were most likely caused by the rainfall and runoff from the local agriculture region. High pH value can occur when the large amount of organic matter present in water, which can cause to increase pH. This could be due to organic matter discharged in lake from the agricultural activity such as fertilize and pesticide, or from the surrounding environment such as decaying and vegetative. So for the temperature of the lake on the water, the A spot is 29 Celsius, B is 28.4, sorry, C is 28.7, D is 28.8, and E is 28.9 Celsius. The consistency in temperature could be due to several factors that influence water temperature, such as weather fluctuation and sample time and location. One possible explanation of the consistent water temperature is high level of sun exposure and heat evaporation in the area. As we know that Malaysia is located on the equator line, as the sun shines on the surface of the water, it heats the water and causes evaporation, which can increase the temperature of the water. Additionally, the lake is in an area with high level of sun exposure, which could contribute to the consistent water temperature. Overall, the water temperature measurement taken from the technology lake indicate that the water temperature is relatively consistent and fall within the range considered safe for consumption. However, it is important to conduct regular monitoring of the water temperature and other water quality parameters to detect any changes or trend in the water quality over time and take necessary action to maintain the safe water quality. So for the controlling device and minute board testing, the data is tabulated on the distance, data transfer, receiver data, condition and remark. For the distance, we take around 5 meter to 50 meter. The received data can also establish connection on using mobile hotspot data. In between 45 meter and 50 meter above, the signal on Wi-Fi range become unstable and unable to control, as it is out of the Wi-Fi range control by it is making the BLYNK to disconnect from the server. The Wi-Fi range on the outdoor limited around 300 meter at best, but the Wi-Fi we be using only the Wi-Fi from the hotspot, mobile hotspot. Based on the output at the 45 meter and 50 meter, the mobile hotspot use a small range connection even without barriers. The data suggests that the system being tested has a limited range for successful data transfer and reception. It may be useful to investigate the cause of the failure at the greater distance and determine if there are any possible solutions to improve the performance of the system at longer distance. It could be possible that the device used for the data transfer and reception is not powerful enough to transmit and receive the data at the distance greater than 45 meter. It could also be possible that the environment is causing interference with the signal at greater distance, such as there are wall and obstacle. And for the final analysis of this project, we will compare the pH value of the lake water with other water solution. We're doing the comparison by using the litmus paper. As you can see on the left side of the slide, you can see I am taking the water solution from the technology lake water. On the right side, we can see the red litmus paper will change to blue, while the blue litmus paper remain unchanged. This shows that the technology lake water are slightly alkaline. For the lemon water, the red litmus paper remain unchanged, while the blue litmus paper changed to blue. This shows that the lemon water is acidic. For the pure mineral water, the red litmus paper and the blue litmus paper remains unchanged. And lastly, the baking soda water, we can also see the red litmus paper change to blue, while the blue litmus paper remain unchanged. We shown that the baking soda is a strong alkaline. For the conclusion, an IoT-based control water quality monitoring system can be used to track various parameters of water quality, such as pH and temperature, in a specific area. The water monitoring system can synchronize and get reading while measure pH value of water on, on an area in a short of time. After testing to verify the functionality of the entire system, the system can monitor excellently In conclusion, the system is more efficient and can replace the old existing system. So my recommendation, in the nearby future, there are several potential areas for future work in IoT-based monitoring of moving water quality, such as improving the sensor technology by developing more advanced sensors for measuring a wider range of water quality parameters with higher accuracy and precision. Wireless communication, wireless communication by developing new wireless communication protocol technologies for transmitting data from sensor to a central monitoring system in a real time. Big data analysis by developing algorithm in technique for analyze and interpreting large amount of sensor data to exact meaningful information and identify trend. Energy efficiency on developing method for powering IoT device in moving water environment, such as renewable energy source, or develop more efficient power management system. By using renewable energy source, we can substitute it with solar panel and others. Integrate with other system, integrated IoT water quality monitoring system with other systems such as weather forecast and flood warning system to provide more comprehensive view of water condition. Machine learning, AI-based approach for anomaly detect and monitoring to improve the accuracy and early detection of anomalies. Develop mobile application to make data access to public. This will help community engagement, water management, and early warning system. So that's all from me. Thank you.